Hello, this is section 5.3 for Calc AB, and today we'll be talking about separation of variables. And we've already emphasized the importance in section 5.2, so we're just going to get into more complex differential equations in this section. And just like in the last section, it is extremely important to make sure you get all of your y's on one side, all of your x's on the other. Your dy and your dx will always be in the numerator and multiplied. Okay, that's very, very important. So in this case, it's pretty easy to see. You'll just multiply over the binomial and then multiply over the dx. And then you do the antiderivative of both sides. But in this case, they're just having you separate the variables. But you could easily solve that. Then over here, so you can see you're going to want to get that 3y by itself. So we subtracted over the x squared, then multiplied over dx to get the y's on one side, x's on the other. So it's just a fun little algebra challenge. So in this case, rewrite the y prime in dy dx and then go from there. So divide over the cosine of x, multiply over the dx, and I think you're good to go. And then here, immediately get that y prime into dy dx, and I moved it off to the side. So now you can easily see that e to the y plus 1 will want to stay with dy, and then we'll divide over the x and multiply over the dx to get 2 over x dx. So just a fun little algebra practice there. Okay, now finding the general solution for this differential equation. So just like what we just talked about, you have got to separate the variables first and foremost. So the y can stay where it is with the dy. So divide over the cosine of x and then multiply over the dx. So that's what I've done so far. Now you're ready to do the integral of both sides. All right. So y, of course, turns into 1/2 y squared equals secant squared turns into tangent. And then the plus c, that plus c absorbs the plus c from the left side. They don't cancel out. They're not the same plus c, but this c can absorb this one from the left. And there's your answer. Okay. Now, you're not going to always be able to get y by itself, and it's perfectly acceptable to leave it like that. All right, so now we're given an initial condition, so of course you know that's going to help us find our c value for the particular solution of. All right, so here's our differential equation. You have got to separate the variables. That is first and foremost, and that's the first thing I'm going to look for. And you have to show that step. You have to do that step to get to the answer. So just make sure you clearly show me that you've gotten your y's on one side and your x's on the other. So for this one, I would add over the x, change that y prime into dy dx. That's what I've done over here. And then I divided over the 3x squared. Where did that 3 go? The 3 is missing in that step. It reappeared in this step. So you've got your y's on one side, x's on the other. Now you're ready to do the antiderivative of both sides. Okay. And then just to solve for c, plug your ordered pair in and go from there. Okay. All right, so find the equation of the curve that passes through this point, has the slope, this at a point xy. So has a slope, that means that's the slope of the tangent line. So that's dy dx is equal to this. So that's what I wrote here. So separate your variables, do the antiderivative of both sides, use your ordered pair to find c, and go from there. So pretty straightforward. All right, now these next 3 examples, I've always tasked the students. These are 3 perfect application problems that align beautifully with the textbook. So I've put here in this section, this is example 4, this is example 5, this is example 6. So I've always tasked the students with, I want you to go home and fill these notes in and use those examples in the textbook. That is a skill you've got to have going into college, being able to use the examples in your textbook when you go home to do the homework in college. All right, so I'm going to stick with that because, I mean, it's really good practice working from the textbook. Okay, but of course, if you have questions and need help, please let me know. But they follow exactly what we've done. You're going to start with your differential, separate your variables, do the antiderivative of both sides, use your ordered pair to find the c value. They're all pretty straightforward. Okay, nothing too weird. But again, let me know if you need help. All right, and then we got one little last lesson closer. And the only reason I put this one on here is sometimes students forget those exponent rules that are really nice. I reminded you on the last one, the last section, we used that, let me find one here, where we base E both sides, and this e to the kx, and then you've got your plus c up here, that can be rewritten. Remember I showed you that can be rewritten as e to the 2x times e to the c, and then that e to the c can be written as just a big plus c out in front. So in these notes, don't forget that you have that capability of rewriting this as e to the x times e to the negative y, because if you were to combine that back together, you would just add the exponents and get back what you started with. But you have to do that in order to separate your variables. So now you can divide over that e to the negative y and then move it up and then multiply over the dx. Now you're able to separate. Now you're able to do the antiderivative of both sides. Okay, so all right, just make sure you're doing your homework. And again, I'm going to emphasize it one more time. Make sure you show me that very important separation of variables step. Okay, all right, let me know if you have any questions.